Now, thank you for joining again, and we are now going to continue with our question 43. As what we have mentioned just now, our question 43 actually talking about the dilution. As what we have done for your experiment previously, what we do is we are taking this one as the stock solution. You have a lot from here where you are having this 0.5 mole per decimeter cube of this solution. This is NaOH. Now from here, you take 25 centimeter cube. So you are going to transfer this 25 centimeter cube into a volumetric flask. Remember the volumetric flask? I hope you can remember. Please know how to state, how to produce this standard solution using two methods, which is the dilution method and also the one from the solid. Okay, now you are going to put in a volumetric flask. Therefore, from the question you see, you have this, the 25 centimeter cube, the 25 centimeter cube, 0.5 mole per decimeter cube of sodium hydroxide solution is here. Okay. Now, what we have known previously, we are going to top up with water. We are going to top up with water until this calibration mark. Add with water. Now, when we are added with water, the concentration will not be 0.5. It will become 0.25 mole per decimeter cube. So now we have to know our first step. How much of solution are we going to produce? Meaning the final volume. Now, when we are talking about dilution, we are actually using the formula M1V1 equals to M2V2. Now, the M1 is actually the 0.5. The V1 is 25. M2, we know that it is 0.25. Someone please get for me what is the value of V2? Is V2 50 centimeter cube?
Yes.
Someone check for me if yes or no, Katun?
Yes.
Okay, thank you. So now, the question wants the volume of distilled water required to be added. That means now you have already 25 centimeter cube. You want to add in water until it becomes 50 centimeter cube. How do we know the 50? It is from our calculation here. Therefore, you have to add in another 25. That's why your answer is B1. Okay, I hope you are okay with this. And now we are going to move on to the next part of the question where we are talking about question 45. Now in question 45, they show you the rate of reaction between the calcium carbonate and the excess hydrochloric acid. The graph is given to you, and you have to know how much time is required for half of the calcium carbonate reacted. Okay. Now, how much is the calcium? This one now, what is the maximum volume of the gas produced? Did you see the maximum volume to be 90 centimeter cube? Okay. We are having this, the calcium carbonate to react with the hydrochloric acid. You are getting calcium chloride, carbon dioxide, and water. And from our graph, we know that the volume of gas produced is 90 centimeter cube. Okay. Now, we know that this is in excess. That means we want to know what is the mass of this. What is the mass of this? So first of all, you have to get the number of mole of CO2. You are taking the 90 centimeter cube, you have to convert to decimeter cube. So you divide by 1000. You are getting your answer as 0.09 decimeter cube. Okay. Now divide with the molar volume, which is 24. Press your calculator. Someone press your calculator. No one,
0.00375.
0.00375 mole. Okay. From the equation, the CO2 is to CaCO3 will be 1:1. So 0.00375 will be is to 0.00375 mole as well. So from here, what is the mass of the calcium carbonate? Calcium carbonate, you have to get the molar mass, you times, what is that? Final answer, someone? No one, calcium 40, this carbon 12, oxygen, how much? 16. So altogether, you are having 40 plus 12 plus 48. You are getting 100. So this one times 100, you are actually getting how many? 0.375 gram.
375.
Okay, now this is our long method if it comes out in your paper 2. Now actually in this case, meaning the mass of the calcium carbonate which is reacted is 0.375 gram. Now if this one come in your paper 2, you have to do like this. Then you get when this is half, okay? When this is half, what is the volume of gas release? When this is half, this is how much? Take this, divide by 2. 0.375 gram divided by 2 will be
0.1855.
0.1855.
75.
1875 gram. Okay. Mass of calcium carbonate, which is half reacted, okay, will be this. So from here, when we want to convert, back, we are actually getting what is the volume of gas release. You'll find that just now initially 90 centimeter cube. When it is half of this, so how much is that? It is 45, right? So from the graph, get for the 45, and you are getting your volume as the 0.95 minute, the time as 0.95 minute. Meaning to say, this is objective question. So at first you have here 90, the maximum. So now you get for the 45 because of the half. Then you bring it and you will find that the time taken here will be 0.95 minutes. This is objective, that's why you can do like this. What I mentioned just now, the long steps, it is for your paper 2. Okay, I hope you are okay with this. And now we are going to move on to our next question, which is question 47. Okay, question 47. Now it shows diagram of rubber J and K. Now what type of rubber J, what type of rubber K? I want you to take note about this part here. Okay, can you see the rubber K has got the linkage, the sulfur linkage, but this one no. And you see this one with more carbon double bond. This one less carbon double bond. Meaning to say this rubber J is unvulcanized rubber, and this K is vulcanized. This unvulcanized rubber, another name, we call it as the natural rubber. Okay, so this question require you to compare these properties of the vulcanized rubber and the unvulcanized rubber. So we are going to look at this. Now, what is a comparison? Of course, the unvulcanized rubber is less elastic. That's why this is wrong. This one should be less elastic. This one should be more elastic. Now, this rubber J is weak and soft. This one should comes there. This one should goes here. Okay, oppositely put. Now, this rubber J, which is unvulcanized, has low melting point. This one has higher melting point. Now, D is your answer. The rubber J, which is an unvulcanized rubber, it is easily oxidized. What is the reason? It is because of the presence of the carbon-carbon double bond. You know that when there is carbon-carbon double bond, addition reaction can occur. So with that, the addition reaction can occur as well. Okay, now we continue on. Next part. We are now going to question 48. Question 48. The equation shows the reaction between the potassium hydroxide and the potassium dichromate 6 solution. Can you see? Okay, you are getting the potassium chromate 6 as well at last, and with water being produced. What happened to the oxidation number of chromium? Which is the chromium? This one, the chromium. This one, the chromium. That means you are going to calculate from here to here. What is the change? Okay, and the pH of the reaction mixture when aqueous potassium dichromate 6 is added into the aqueous potassium hydroxide. That means when this is added to this, what is the change in the pH value? Okay, now initially this potassium hydroxide, we know that it is at the pH which is higher than 7 at this range. At this range, this range. Now, when this solution is added into it, this is a neutral solution. Added into it, it will make it to be less alkaline. Do you agree? When it is less alkaline, this pH value initially from here, let's say, it will drop. Okay? That's why your B is wrong and your D is wrong. You left your answer A and C only. Now, next part. We are going to calculate the oxidation number of this Cr. Okay? Now, for this, it will be 2 positive 1 plus 2x plus 7 times of negative 2 equals to 0. So what is the value of x? Someone get for me, please. Positive 2 minus 14. So you are getting 2x minus 12 equals to 0. Agree? So x will be equals to positive 6. Now what about this? Ignore the 2. When you calculate, 2 times of positive 1 plus x plus 4 times of negative 2. So x will be equals to positive 6 as well. Okay, now actually you don't have to do any calculation. I teach you from where you can see. Can you see the 6 here? Can you see the 6 here? The 6 means it is the oxidation number of the chromium, positive 6. So your answer will be A, apple. Okay, now we continue. Next part, which is question 49. Now, question 49 shows you two graphs of volume of oxygen against time. Now, which graph will have a higher rate of reaction? Your answer should be 2. Can you see this line and this part? This part? It is having a higher rate of reaction. And for curve 1, this one, it represents the decomposition of 25 centimeter cube, 0.5 mole per decimeter cube of hydrogen peroxide with the manganese 4 oxide as catalyst at temperature 30 degrees Celsius. Now they are showing you two factors. First factor with the catalyst, second factor the temperature. Now you want to get curve 2. Curve 2 means number 1, the rate of reaction is higher. What do you know about curve 2? For curve 2, where's my this? Okay. For curve 2, you know that the rate of reaction will be higher. Okay, this is the first point. Second point, can you see this graph and this graph? This will be produced lower volume of oxygen gas. How do you make the volume of oxygen gas lower? Then you have to take care of the MV over 1000. You calculate the MV over 1000, you have to make it to be a lower number compared to the set one. Then that will be your answer. So how are we going to talk about that? Now, you look at the option given to you. The volume and the concentration actually enable you to calculate the MV over 1000. Now, did you see when you want this one to be at higher rate of reaction? Okay, if you don't change the temperature, what can you change? You can change the concentration. Okay, so now when you do your calculation, if you want this to be maintained, first of all, you do your MV over 1000 first. Okay, you get a number for A, a number for B, a number for C. Everyone calculate now to give me the number for the MV over 1000 for A, B, C, and D. Okay, GK do for A. This some you do for B. Xavier do for C. Sangita do for D. Okay, GK, A, what do you get?
0.025.
Okay, for A, you are getting 0.025 mole. Next, Samuel, B.
0.007.
Next, Sangita. And this is Xavier.
Xavier. 0.015.
0.011.
15.
Okay, Sangita.
0.01.
Okay, now you see, we have to eliminate one answer first, which is the 20 degrees Celsius. You want it to be at higher rate. If you put 20, and the concentration is still the same, then you don't get a higher rate of reaction. So part D is out. Left A, B, and C. Did you notice that A, B, and C, the temperature is the same? So the concentration will be determining it, whether it will be having a higher rate or a lower rate. So now we are going to get this higher concentration. Initially, we are using 0.5. So A, B, C fulfill the requirement, but we want the number of mole to be lower than the set one. Set one, what is the number of mole that you get? Someone please calculate for me. Can I hear from Tiban for set one?
0.0125.
Okay, for set one, you are getting 0.0125. Can you see this is higher? Compared from A to B, from A to set one. So this is higher, so this is out. Can you see this one is lower, this one lower, so this is the answer. This is not the answer also because this is higher, C is higher. So the answer is B point. Okay, any problem? Any more problem for this set? No, okay, thank you very much. So we have already completed on the discussion on this set. So now today what are we going to do is I need you to do your remember the lemongrass set. Okay, you complete the structure which is 4, 5, and 6. Structure 4, 5, and 6 you complete today. Okay, then tomorrow morning I am going to discuss the questions on the lemongrass 4, 5, and 6. Can I? I hope you can. Then I'm going to post the answer for the another set of objectives that you have not checked your answers yet. So you please check your answer and you do the same thing. If you have any problem, you please jot down in the group which is the problem that you have for the questions. Then we will discuss about it on the next coming lesson. Okay, so today your homework will be on the lemongrass set when you are going to do question 4, 5, and 6. Don't forget to study about your paper 3, the set of experiments that I have given to you. Okay, I hope you are well, and thank you for logging in, and I'll see you tomorrow at 8 o'clock in the morning. Thank you very much. Take care, and bye bye.